Okay, so I want to start out, again, this is Unit 2, Day 6. I want to review what we did in Day 5, where we learned that adding numbers, whether it be outside of the function, so this was an absolute value function, we added a 3 afterwards, so you're supposed to absolute value, then add 3, or adding numbers inside will shift the graph, it'll translate it up, down, left, and right. And, we learned down here in this graph, or in this little table, that if you have a plus k on the end, if you have a number you're adding on the end, positive means up, negative means down. If it's inside the function, this yesterday was an absolute value, it's the opposite of what you think, left and right. If you put a negative in front of the function, it's across the x-axis, so it's going to flip down. If it's inside the x, it's going to flip across, so left and right. And then we did some compression, vertical compression and stretch. But today we're going to do a different function, like a couple different functions actually, but it's the same idea. So now instead of having an absolute value of x plus k, I have the square root of x plus k. And what's going to happen is it's going to be the same thing. It's going to be, if it's a plus k, so that's after the function, that's going to be up. So it's going to shift up k units in that direction. So then if it's a minus k, it'll be down k units. If it's inside the square root, so this is what it looks like to be inside the function. This is inside the square root. It's left and right. It's the opposite of what you think. So a plus would be left, and a minus is going to be right. Okay? So now, maybe it's been a while, or maybe you've never done this. The square root function itself, what does that look like? The absolute value function was a V shape. That was something to memorize, make your life a whole lot quicker and easier and faster. And but a square root function now, we're not quite, maybe you don't remember. So if you don't remember, you can always make a quick t-table and fill in x value. Don't just put -2, -1, 0, 1, 2, because not all of those are easy numbers to square root. In fact, none of the negatives work. You can't square root a negative. If I try to square root a -1, there is no number times itself that equals -1, because you can get a negative when you square something. So there is no square root of -1. So there's no negatives. This is not going to be graphed on the left side of the y-axis. There will be no graph here because the domain is only non-negative numbers. So 0 and above can be plugged in. Now the square root of 0, so the square root of 0 is 0. The square root of 1 is 1. And then the square root of 4 would be 2. So we'll plot those points. And here's what we get. So 0, 0, 1, 1. 4, 2, and you get this graph that kind of goes this way. And if you plugged in 9, you'd get 3. Square root of 9 is 3. So it's going to gradually go up and to the right, but it's going to go to the right faster than it goes up. So this would be A. That's my A graph. Now, if I was going to graph B, you don't need to make another t-table for it. It's just going to be this parent function, and it would be down 3 units. So I'm going to take all of these points, and really you could just take this starting point, move that down 3 points, up 1, right 1, up 1, right 3. That's kind of the pattern. So up 1, right 1, up 1, right 3 is kind of that square root pattern if you want to just memorize that. So that's your B. And then if I wanted to do C, well, I'm going to take the original A, I'm going to move it up 2 units because that's an after the function addition. So we're going to square root, then add 2, that's going to be up. So all these points go up 2 units. So I just take the first point up 2 units, and then up 1, right 1, up 1, right 3. And then the last one here, I've got a couple things going on. I'm going to move it up 2 units, which is C. So C and D look a lot alike, but then I've got this negative here, which means flip it. It means flip it down. Okay, so I'm going to, instead of having it go up going this way, it's going to be going down this way. So instead of up 1, right 1, it's going to be down 1, right 1, down 1, right 3. So it's going to reflect that way. Okay, and that's a D. Okay, so that's kind of how this square root one works. Now let's do some left and right shifts. So original, there's A, there's my original square root function. a -2 on the inside. It's on the inside, so it's left and right, but this one's opposite what you think, so it's going to be right 2 units. So all these points go right 2 units. Okay, there's B. Then this one is a +3 inside, so that's going to be left 3 units. So all these original A points go left 3, so left 3, left 3, left 3, like something like this. There's C. And then here's my kind of a double whammy here. We're going to shift 5 to the right, and we're going to flip down. We're going to flip it down over the x-axis. So this is going to go, here's my original parent function, go 5, 1, 2, 3, 4, 5. And then instead of going up and to the right, I'm going to go down to the right. So something like this. That's D. Okay. So down here, we're going to do a couple. They're combinations. So we got a bunch of stuff going on here. So maybe just write down what you need to do. So this +1 means up 1. This -2 means right 2. Okay. Doesn't matter what order you do this. You can go right 2 and then up 1, or you can go up 1 and right 2. But here's where I normally would have started with my parent function. So I'm going to go up 1, right 2, and then from that point, up 1, right 1, up 1, right 3, and get my square root. I've got a up 1, and then a reflect. So reflect. And that's about the x-axis, so it's going to be a flip down. So original parent function started here, go up 1, and now instead of going up to the right, I'm going to be going down to the right. Okay, something like that. And then here I've got a -4, which is down 4. I've got a +1, which is left 1. Remember the opposite of what you think. So it doesn't matter what order you do it. So I'm going to go down 4, 1, 2, 3, 4, and then left 1. That's going to be my starting point. From there, up 1, right 1, up 1, right 3. And that's the pattern for the parent function. Up 1, right 1, up 1, right 3. Okay, so let's flip this guy over. And now we have a new function. Okay, so now instead of an absolute value of x, or instead of a square root of x, we have an x squared in here. But it's going to follow the same pattern. If it's got a +k, so this is outside the function. It's after the function's being executed. That's up. -k is down. Here, this is what it looks like to be inside the function. So this is x minus h and the whole thing squared. Opposite what you think. So this would be right, and then a plus would be left. So now, what does an x squared look like? Hope you remember this from Algebra 1. Been a couple years ago, but if you don't, make a t-table real quick. So if I plug in -3, -3 times -3 is 9, -2 times -2 is 4, then 1, then 0, then 1, then 4, then 9. Okay, and I'm going to plot these points. And the -3, 9, and the 3, 9 are off the graph, but it's going to make that U shape. Remember a parabola, the U shape. Okay, so there's the original, the parent function, and now we're going to do some shifts with it. So if you just think of it starting here, and I go up 1, right 1, left 1, and then from there I go up 1, right, or I'm sorry, up 3, right 1, up 3, left 1. That's kind of your pattern for getting the right shape down. So I got a +2, that's up 2, up 1, right 1, up 1, left 1, and from there I go up 3, right 1, up 3, left 1. So there's A. This might get kind of ugly in here, but it's okay. We're going to get a lot of stuff being graphed. This one is down 5, so 1, 2, 3, 4, 5, up 1, right 1, up 1, right 3, up 1, left 1, up 1, I'm sorry, up 3, left 1. Connect them. That's B. This guy here, this would be up 4 units. So it's going to be right here's where it's going to start, and that's about all you can really see of the graph. So there's C. And then this guy here, I'm going to go up 4, but then I got to reflect it. I'm going to flip it over. So I'm going to go up 4 units, 1, 2, 3, 4. But now it's going to get flipped over. So it's going to be down and then right one, left one, and then from there down 3, down 3. It looks something like this. So there's letter D. Okay, left and right graphs, you probably kind of guess it here, but this is what it looks like to have a left and right shift. It has +3 on the inside, that's left 3. This one would be right 3. Okay, so let's graph these guys. So normally a parabola, the vertex is right at the origin, so I'm going to go left 3, 1, 2, 3, up 1, right 1, up 1, left 1, up 3, right 1, up 3, left 1. Okay, there's A. B, so let's go the other direction. 1, 2, 3. See how quick these problems are meant to be. If you memorize a shape, they're pretty fast. I mean, you don't have to spend a lot of time doing this. +2 would be left 2. So 1, 2. There's C. And then for D, I've got a left 3 and then a flip. So I'm going to flip it down. So I'm going to go, see, this is going to look like A because A was left 1, 2, 3, and now it's going to go down instead. There's letter D. Now let's do some combinations. So down here, some quick combinations. I've got an up 2. I've got a left 2. Again, you can go left 2 and then up 2. It doesn't matter the order on these. So the translations and that does not matter. So up 2, left 2. Okay, there's my, and then up 1, right 1. Something like that. I got a up 2. I got a left 2. Let me write that. So up 2, left 2, and then a reflection, and flip it over. So it's going to be this same guy. So up 2, left 2, but instead of going open up, it's going to be open down. It'll look something like that. And my last guy here, that's a down 3, that's a right 4, and then that's a flip. So we got to flip it over. So I'm going to go down 3, right 4, right here, and now instead of going up and to the right, I'm going to go down. It's going to be open down. Something like this.